For today's algorithm, we're going to be discussing building a linked list from an array. Now, the question that we need to solve is, given an array A containing integers, write an algorithm that returns a linked list containing the members of A. So, to do this problem, we're going to need to recall what a linked list is. Now, a linked list is a data structure consisting of a collection of nodes which together represent a sequence. Now, a node is an object and a member of a linked list that has a data field and a reference to the next node in the list. So this sequence of nodes makes up and is called a linked list. So our goal in this problem is to take the members of an array, which in this case are integers, put them into nodes and make those nodes form a linked list. So before we dive into trying to build this algorithm, let's think intuitively how we want to approach this problem. Now we know there's probably many ways we can build this linked lists. We can either start from the front of the linked list and work forwards, or start at the back of the linked list and work backwards, depending on what we want to do. We can do this iteratively or recursively. And it may make sense to solve this problem recursively because a linked list is defined recursively. It's a recursive construction, by that I mean that every node is defined in terms of its next node, and each node is defined as well by its previous node. So what is our goal here? How are we going to solve this problem? Well, we essentially want to iterate over the array and construct new nodes to append to our previous node's next reference pointer as we go. So each new node is going to contain the value of the array that we currently are indexing at. So now that we've figured out that, let's actually attempt to write this algorithm together. So our algorithm, we'll call it build list. And let's actually decide to write this iteratively first. Then we'll write it recursively after. So we'll call it build list iter for iteratively. It's going to take one parameter, that being an array, which we'll call A, and it's going to output a node. And why does it output a single node? Well, that's because if we have just the head of the linked list, then we have the entire linked list as far as we're concerned. So the first thing we need to do in this method is define the head of our new linked list we're going to create. So we're going to make a new node. We're going to call that head. And we want to be able to keep a reference to the head, but also traverse over this linked list. So we're going to make a new pointer to that same starting node, and we're going to set its name to cur and say that cur equals head. Now cur, of course, short for current. This is going to be our current node as we traverse over the linked list. So cur equals head. Now we want to traverse over the array, and how we do that usually is with a for loop. So we're going to say for I equals 1 to a.size. Now notice here that we are using 1-based indexes of this array, which is why we don't need to worry about size minus 1 and starting at 0. So we're going to start at 1, which in our pseudocode here, we assume to be the first member of the array. Now the first thing inside of this loop at every iteration we're going to want to do is first construct a new node in which we can put our index, our current index's value inside of. So we're going to make a new node, let's call it new node, and set new node's data to the value at our current index of the array. Now, of course, as I said, every node has two fields. It has a next field, which is another node, and a data field, which in this case is integers. So we're just going to grab the integer from the array and put it into our data field. Next, we're going to set our current. So this is going to be our tracer. We're going to set our tracer's next to be this new node. And then we're going to set our tracer to be the new node. That way, when we enter the next iteration of the for loop, we can just put the next node we create at the end of the linked list, tracing over the linked list with cur. And finally, we need to return the head of this new linked list. However, what you'll notice is that our current head that we started with is just an empty node with no value. All it has is a next pointer, which is going to be the first member of the array. Since we want to start at the first member of the array, we're going to return head dot next to give us the actual linked list that we want to return here. So this code seems to be pretty straightforward. It's just going to continuously append to the linked list using this current tracer as we move along, exactly as we said we were going to do in the intuition. But let's take a look at the recursive solution to this. Let's build a recursive solution using the same idea, the same logic. Now we're just going to write our code a little differently. So let's title this build list recursively. It's going to take this time 2 parameters. Now, why do we need 2 parameters? Well, again, like the previous example, we needed a way to trace over the array. And so we used a for loop. But now we're going to use recursion to trace over the array. That means we're going to have to keep a reference to where in the array we currently are. Another option we could have taken is we could have destroyed the array and created a smaller array at every iteration, and always took either the first or the last element. However, this is just cleaner, so we're doing it this way. One thing to note is that if a user was using this method, we'd probably have to write a wrapper method that takes only an array and passes in our starter integer I, 0, right? Because given a client might not know that they need to pass in 0 into that second parameter. But or if they want the entire array to be turned into a linked list. But for our purposes, we're just going to leave that extra parameter there. So how do we construct methods recursively in general? Well, the first thing we're going to have to consider is what is going to be our base case. And then a base case in this situation is pretty easy. If we've gone through the whole array, we want to be done with this method. So how do we know if we've gone through the whole array? Well, if I is greater than the array size, then we have already we've already created every node we need to create. Now, this means that we need to return, and we need to return something. The logical thing to return here is going to be null, because once we've already added our last element, we want its next pointer to point to null. So we're going to return null. That's our base case. Now, let's look at our recursive case. Well, the first thing we're going to want to do is create a new node, as we did in the iterative case, and make its data equal to our current index of the array. So new node.data equals the array at index I. Now we need some way of traversing over this array, and we're going to do that recursively using these recursive calls to update the index one by one. So we're going to set new node.next to be the output of the recursive call of build list recursively that takes the array and increments the index by 1. That means in the next recursive call, we're going to now be indexing, let's say we were previously indexing at 1, we're going to be indexing at 2. And then the next recursive call, we're going to be indexing at 3, etc. And lastly, we have to return new node, which is going to be the new head of our linked list once we're finished here. So of course, since we call these recursive calls before we resolve them, means we're going to append them to the stack and then pop them off in the reverse order, which means the first thing we're going to resolve is creating that new node at the final index of the array and work its way backwards, setting each previous node that we just created to the next of the node before it. That's how we're going to build the list in this situation. Again, a similar concept to the iterative solution, this time just written in a different way. Now let's consider the runtime of both of these solutions. Well, it's pretty clear that we need to traverse the array at least once. And in our situations, we traverse it only once. So we can say that the runtime is proportional to the length of our array. Now, if we consider the array to have n elements, we're going to say that the runtime is of the order of n, or belongs to the set big O of n. And this is the case for both the recursive and the iterative solution. But as I alluded to, the recursive solution does require the use of a stack to store those recursive calls. So in terms of space, maybe it's preferred to go with the iterative solution, but in terms of clarity, I think the recursive solution in this situation definitely wins. Anyway, that's all for building a linked list from an array. If you enjoyed this video, don't forget to like, comment, subscribe, hit the little bell icon. And as always, we'll see you in the next video.